Okay, next up I want to figure out the molecular shape of IF3. So as usual, begin with your valence electrons. I have 7 plus 7 by 3. And this is going to give me 7 by 4, which is 28 electrons. Okay, and then from here, I would have iodine in my middle, and then it makes most sense to have the fluorines around them, because here you can't tell which one can make the most amount of bonds, because they can both make one bond, technically. And so I'm going to fill in fluorines octets, and then count everything that I have. So I have 6 by 3 plus 3 by 2, which is simply 6 by 4, which is 24 electrons. And so I have 4 electrons left over. Fluorines octet is already full. It's already made its optimal amount of bonds, so it makes most sense to place them on my central atom, which is the iodine. And so now all of my valence electrons have been taken care of. I can double check on my formal charge. Fluorine is 7 minus the 6 in lone pairs minus the 1 in the bonding pair, 0. Iodine is going to be 7 minus the 3 in bonding pairs minus the 4 in the lone pairs, giving me a 0, 2. And then, so because the formal charge is minimized and the valence electrons are all taken care of, this is going to be our best structure. And so now I need to figure out the number of terminal groups. And it is going to be 3 plus the 2 lone pairs, and so that is 5. And it would have notation AX3, E2. So terminal atoms represented by the X, and E is the lone pairs. And so from this, I just go to my VSEPR chart. So to find the electron geometry, it will be dictated by the way electrons are generally arranged around your central atom. So you're not really taking into account which electrons are in bonding pairs or which electrons are in lone pairs. And so it's just the basic geometry that you would get down to if there were no lone pairs. And so if you just had 5 groups. And so that would be trigonal bipyramid. And the molecular geometry will now account for which ones are bonding pairs and which ones are lone pairs. And it will describe how the molecule, the 1 iodine and 3 fluorines, would look. So when you're not thinking of these 2 lone pairs. And so it would be, you come down to the 5 and then you account for how many lone pairs you have. I have 2. So it's going to be T-shaped. And so if I drew it out, what it should look like is the iodine. I have my 3 fluorines. And then towards the back, I have the first electron pair, and towards the front, I have my second electron pair. So it's called T-shaped because of just its general look. The 3 groups that you can see are arranged in a T sort of shape. All these other 2 look seesaw-ish. But you focus on the main 3, so T-shaped. And so the molecular shape is A, T-shaped.